Welcome to Guide Mia. Today we're going to talk about round-tripping an implant case between Cympha Studio and Guide Mia implant software. This one is for clinicians and implant designers collaborating across the browser and the desktop. Either side may have created the case, and either side can review, adjust, comment, and hand it back. By the end you'll know how to open a colleague's implant project in Studio, review and edit the implants, read the design log and append your own entry, swap in a separate implant plan when you need to, and save back to the same project file so the desktop application picks up your changes cleanly. Budget about 15 minutes for the first case, most of that is verifying you have the right DICOM, and 5 to 10 minutes per case after that. Follow along on screen, or listen now and read the written guide later. The core idea of this workflow fits in one sentence. There is one project file, and both applications read and write it. The implant project, the PIE file, is the same document whether it's open in Guide Mia implant software on a desktop or in Cympha Studio in a browser tab. There's no separate Studio version, no export-import dance, no lossy conversion. Either side can create the case, and either side can review it, move implants, and comment. The conversation itself travels inside the file too, as a design log, a running commentary, entry by entry, author by author. And the promise that makes the whole thing trustworthy: when Studio saves, it retains the full document and rewrites only the pieces it modeled, so everything the desktop wrote, including parts Studio doesn't understand, survives the round trip untouched. Two files, and the second one is the one people get wrong. You need the colleague's project file, obviously. But you also need the matching DICOM folder, the original CBCT series the project was planned against. Studio matches a project to ACT by the series instance UID, the same identifier the desktop software uses. That means ACT from a different patient won't match, and, this is the subtle one, a re-exported series with a new UID won't match either, even if it's the same anatomy. Why so strict? Because implants in the project are positioned in CT voxel space. Without the matching volume, Studio literally cannot render them in 3 dimensions. So if you only receive the project file, stop now and ask the sender for the CBCT folder, the original, not a derived copy. First, put Studio in the right context. In the top bar, open the workspace nav and pick Implant. The hamburger menu narrows to the file actions implant work needs, DICOM, the implant project, optical scans, pictures, open URL, reset camera, clear scene, and the user guide. Remember, a workspace is a menu filter, not a mode. Nothing in your scene changes when you switch. And often you won't even do this by hand. Opening a project deep link from a colleague's email or a shared URL switches you to the implant workspace automatically. So the manual switch matters mainly when you're starting from local files, which is exactly the situation in this walkthrough. With the workspace set, the loading order comes next, and the order is the part that matters. Step 2. The DICOM has to be in the scene before the project loads, because Studio needs the volume both to render implants in 3 dimensions and to verify the patient match. From the hamburger menu, open DICOM, and choose the folder containing the one series. Studio decodes it right in the browser, nothing is uploaded anywhere. Your signal that the volume is ready is the slice rows appearing. While you're here, it's worth opening the View Tools panel from the left floating strip and tuning the HU threshold and opacity until bone is easy to see. You'll want that contrast when you're inspecting implant positions later. One prompt to decline: if your deployment has Cloud Implant APIs, Studio may offer to import a cloud treatment plan for this series. Skip it, you're about to open a project for the same case, and the project will provide the implants. Now the project. Hamburger menu, open implant project, the file picker is restricted to the project format, and pick the colleague's file. What happens next depends entirely on the UID match. If it matches, everything unfolds at once, the implants load, the model's browser opens automatically, and the implant tools toolbox in the left strip expands so the parameter panel and the design log are visible. If it doesn't match, no DICOM loaded yet, or the loaded CT belongs to a different patient, Studio shows a DICOM required dialog, which names the patient stored on the project when that information is available. Click Open DICOM inside the dialog, pick the correct folder, and once the UID checks out, the implants load automatically. And note the guardrail: you cannot save implants back to the project while the DICOM is mismatched. Studio blocks the write on purpose, so a plan can never be silently re-anchored to the wrong scan. Before you change anything, understand what your colleague built. In the model's browser, each implant is its own row, and when the project carries the data, Studio enriches the row with the brand and product line, the total drilling length, and the sleeve dimensions, inner diameter by outer diameter by height, in millimeters. Click a row and that implant becomes the current implant in the toolbox. The diameter, length, apical, brand, and catalog fields populate with the values from the project. Use that as a sanity check against the treatment plan. To inspect spatially, double-click the implant body in the main view. The positioning gizmo opens, with axis handles for translation and rings for tilt. And here's the reviewing power move. With positioning active, the View Tools panel offers a gizmo slice mode that aligns the slice panes to the implant's own axis, the natural way to verify parallelism with adjacent roots, or sleeve clearance from the inferior alveolar nerve. This view is what the whole matching ceremony was for, the colleagues' implants rendered inside the actual volume they were planned against, inspectable from any reformatted angle. When the slices follow the implant axis, questions that are hard in free three-dimensional rotation become easy. Is this fixture parallel to the adjacent root? Is the sleeve clear of the nerve canal? Does the apex sit where the plan says it should? Spend your review time here, before touching a single parameter. Because the next stop isn't the geometry at all, it's the reasoning behind it. Every placement you're looking at was a decision somebody made, and in this workflow, those decisions are written down inside the very file you have open. The design log is the part of this workflow that turns a file exchange into a collaboration. It's the planner's running commentary, stored inside the project file itself, not in an email thread, not in a chat app that half the team can't search. While the project is open, the Implant Tools toolbox shows the existing entries, grouped by author, in the order the desktop software wrote them. Read them before you change anything. The previous designer probably explained why placements are where they are, why that fixture is tilted, why that site was avoided, what constraint drove the length choice. Editing first and reading second is how collaborators end up silently undoing each other's careful decisions. 2 minutes of reading, then edit with context. And when you're done editing, you'll add your own entry to the same log. That's step 7. Editing works exactly like Studio's native implant planning, so this will feel familiar if you've seen that lecture. For a new implant, optionally open the embedded catalog and pick a brand and size. Selecting a row fills the diameter, length, apical, brand, and catalog fields. Enter the universal tooth number, 1 through 32. If that tooth already carries an implant, Studio shows an alert and refuses. Pick another tooth or remove the existing one first. There's no silent double placement. Then click Add, watch the status line prompt you to click in 3D or a slice view, and click the site. The implant appears with its sleeve at the clicked point, and you refine with the gizmo in 3 dimensions or on the slice panes. For an existing implant, click its row in the model's browser to make it current, edit the fields, and click Update to regenerate the geometry. Same rule as always, Update stays disabled while a placement is pending, so finish any outstanding and click First. Now close the loop. Below the existing log entry sits a text area and an Add Comment button. Type your review note, and be specific, something like reduce the length on 16 for sinus clearance, verify on the coronal slice. Vague comments waste the next reviewer's time, specific ones save a phone call. Click Add Comment, or press Ctrl-Enter inside the text area, Command-Enter on a Mac. Your entry is appended under your name, and it's persisted to disk on the next save. Then the save itself, hamburger menu, Save Project. Studio writes your implant changes, new placements, transforms, design log additions, back to the same project file name. And remember the preservation promise from the start. Studio retains the full document and rewrites only what it modeled, so every non-implant segment and attribute the desktop application wrote is still there. The status line confirms the saved file name. Send the file back, and your colleague picks up exactly where you left off, in either application. There's a second file format in this story, and it's worth knowing when each applies. The implant plan file, the IMP format, is Studio's native plan snapshot, XML metadata only, no mesh blobs. Reach for it when you don't have a project file yet but want to share an implant plan with someone on a different desktop application, or when you're importing positions from another tool that exports this format. Inside the implant toolbox, Export Plan writes all current implants to a downloadable file, and Import Plan loads placements from one, adds the sleeves, and deliberately skips any teeth that already have an implant, so you can't double place by accident. But be clear, the two formats are not interchangeable. While a project is active, Save Project writes back to that project. To produce a plan snapshot from the same scene, you use Export Plan explicitly. Project file for the collaboration, plan file for the handoff. That's the division of labor. Let's talk about the shape of the ongoing collaboration, because that's what this whole workflow is for. The project you just saved is the very same file the desktop application opens. There is no separate Studio version of the project, both applications read and write the same document, and Studio's full document preservation means the non-implant parts survive every round trip untouched. So the loop runs like this. Your colleague opens the saved project in GuideMia implant software, reads your design log entry, and either accepts your changes or replies in the next entry. They save and send the file back. You choose Open Implant Project again, Studio matches it against the DICOM you still have loaded, so there's no reloading ceremony, and you pick up the new state. Round and round, with the reasoning carried inside the file. One boundary to know, project pictures and screenshots travel separately from the implant project. If you want gallery captures attached to the case, you'd save a Cympha scene project alongside it, but note that while an implant project is the active project, the Cympha project save targets are suspended in that same session. The two formats are mutually exclusive, so you switch between them through the relevant menu entries rather than having both live at once. 5 things go wrong often enough to name, and we'll take them 3 and 2. First, and by far the most common, the DICOM required dialog appears even though you're certain you loaded the DICOM. The series instance UID on your DICOM doesn't match the one stored in the project. The classic cause is a re-exported CBCT, Many viewers reassign identifiers when they export, so the anatomy is identical but the identity isn't. The fix is not to try harder, it's to get the original DICOM folder from whoever captured the CBCT, not a derived copy. Second, the implant rows in the browser look bare, no brand, no sleeve dimensions. Older projects, or projects that came through a third-party importer, may simply not carry those enriched fields. Nothing is broken, the implants still render and still edit normally, only the row summary is sparser. Third, you try to open an implant project and a Cympha scene project at the same time and Studio won't let you. That's correct behavior, the two formats are mutually exclusive within a single session. Save your work in one, then open the other, and watch the menus enabled and disabled states, because they tell you which save target is currently active. And the last two, which share a personality, they both look like nothing happened at all. Save project appeared to do nothing visible. Before assuming failure, watch the status line at the bottom of the viewer, that's where Studio reports the saved file name, and very often the save did succeed and you simply didn't see the confirmation. If the status line is silent, the browser may have blocked the file write, because some configurations require a user gesture in the same tick. The reliable workaround is to trigger Save Project from the menu directly rather than via a keyboard shortcut. Second, the design log text area won't accept Control-Enter. That shortcut is only handled while focus is inside the text area itself. If you typed your comment, then clicked somewhere else, the viewer, a model row, and then pressed Control-Enter, it does nothing at all, because outside the text area the shortcut has no meaning. Click back into the text area, then press the shortcut, or simply use the Add Comment button, which never has this problem. Neither of these is a data loss situation, but both waste 10 minutes if you don't know where to look. Everything here is written out in full, dialogues, formats, and every failure mode, at cympha.com. Open Docs and find the guide on round-tripping an implant case between Cympha Studio and Guide Mia implant software. If cross-team implant work is your daily reality, subscribe. We're covering every Cympha workflow in this series, one lecture at a time. Thanks for watching, and we'll see you in the next one.